Once data has been collected, we need to analyze it. And we're going to talk about a variety of different techniques for that. The first is called conditional formatting. And so here's an activity where students were asked to look at a variety of different kind of mysterious photos and then try to match them with different possibilities here. So it's basically a big matching test. Can they look at this list here and try to find a picture there which matches that? So as they go through the list, they might open a particular one right here and then see that and try to figure out what that is. And they enter it into a form which puts data into a spreadsheet like what you can see here. Now, the colors that you see right here are generated automatically by conditional formatting. So the way that they're done right here is if I was to click on a particular column, heading right there, I'm just going to widen that up so you can see a little bit easier, and then looked at the conditional formatting, you can see that the conditional formatting is saying if the text contains 16, paint this green. Now, we could also add another rule just to show how this is working. Let's say the text does not contain 16, and let's make it red to indicate that it was an error. So now if you'll notice, this column will change, and anytime that there is something that does not include 16, like 32 or 17 and so forth, it's going to be now marked in red. And so this is called conditional formatting. Now, looking back at the density and buoyancy activity, one way we can use conditional formatting here is when the data comes in, we can see where the student's actually collecting the right type of data. Now, this one here, they were asked to try to get 1, 2, 3, 4, and 5 block combinations that just about were neutrally buoyant, neither sank nor float. Now, one way of ensuring that they do that is that you can't use anything more than 90 grams for any combination. So if we had the data table set up like this, and let's just choose this column here, and clicking on that little triangle that appears once you select the column header and go to conditional formatting, you can say I'd like to do a conditional formatting that if the value is greater than, let's say, 90, we're going to turn the background color to red. Now what that'll do is that'll highlight data immediately. The students will say, oops, I chose something too massive, and as soon as they enter the data, they'll say, oh wow, I've got to redo that, and then they're going to enter, maybe make a change. Instead of 90.5, they'll try another one which is maybe 85, and you can see when they do it, it turns green. And so that way they can correct any errors before they proceed. So there you've seen two applications to conditional formatting. Here's one with that was just done last night by a student in my class, and his activity here was to analyze the effects of pH and temperature on enzyme activity. So it's a classic activity where you take chicken liver and place it in hydrogen peroxide and then look for the amount of bubbling and so forth. Now in this particular case, he took some paper discs, happened to be chromatography paper, that would sink, and then if a lot of oxygen molecules produced by the degradation of hydrogen peroxide aggregated onto those little discs, they would float to the surface. And the time it took them to float to the surface is a function of how much oxygen is being produced, or at least roughly correlated. So the students from the class entered this data. There was 3 groups, and you can see that this is the time that it was taken for the discs to rise. So in test tube 1, where it's just water, and we can see that it took about 0.5, and that was with the water and the liver, I should say. And then as they scroll through here, they can see the different effects. So if you have hydrogen peroxide, water, and liver, this is the time it takes. However, if you had had hydrogen peroxide and sodium hydroxide and liver, this is the time it would take. Well, the data table is kind of interesting, but it doesn't really shout out at you as to what's going on. So we're going to do some conditional formatting here. And I'm going to highlight all 5 columns by simply selecting all of them there. And then I will choose here conditional formatting for that entire section. And we're going to say that if the value is, let's say, less than equal to, let's say, 3, we're going to turn the background color to green. And what that's going to do is that's going to say if they float to the surface really quick, that means the enzyme activity is still very strong. But let's add another rule along with that. This time we're going to add a rule here to say that if it is greater than, all right, let's say greater than 3 or equal to, we could set that as well. We're going to change that text to yellow, and so that will highlight the ones that are taking longer. And finally, let's add another one. Just say if the text contains a dash, then we're going to say that there was absolutely no effect on that one. So let's color that one there. Let's say dark gray. Okay. In this case, it's indicating when I say no effect, I should have said that it was just taking too long to record. So let's say over 100 or something like that, and they just ran out of time and put a dash. So when you plot that, all of a sudden you see the visual data and you realize, wow, if there's no liver, in other words, no enzyme present, you don't get any, the discs don't rise at all. In other words, there's no oxygen produced that doesn't aggregate on the discs, they don't rise, which is what you would expect, no enzymatic activity. If you put it in hydrochloric acid, apparently the hydrochloric acid is denaturing this, and again, the discs don't rise at all, and that's what those dashes mean. Now when you come over here, you can see that, wow, one person here, the discs never rose, where the other ones, in about a minute or so, they came to the surface. The idea is that, is this an outlier, or is this part of, just a poor data or whatever? Well, at least we can now discuss it. We also see a pattern very clearly when things are arranged by color. We can see that the green indicates that the enzyme is active, the yellow indicates that it's been slightly deactivated, and the gray indicates that there is either no enzyme at all, or the enzyme that was denatured sufficiently so that it had no effect on the substrate. So here you can see the value of conditional formatting in terms of analyzing data. And again, we encourage you to use that in your data tables.